Okay everyone, welcome back to SET Math for week 4. Jumping into this one, there was a little bit of a mishap with last week's assignment. Instead of linear inequalities, I believe I went over nonlinear systems instead. So today I'll be covering 3 questions for linear inequalities and also 7 questions for nonlinear functions. Okay, so just get started. We have this question: cost of tickets. A local transit company sells a monthly pass for $95 that allows an unlimited number of trips of any length. Now, these tickets can cost $150, $250, or $350 depending on the length of the trip. What is the minimum number of trips per month for which a monthly pass could cost less than purchasing individual tickets for trips? So, for this question, because we're looking at the minimum cost, so the bare minimum, we can actually just account for the most expensive ticket, because that would mean, the pure minimum number of, individual tickets is, the easiest way to find that is using the most expensive ticket, because, we're just assuming we're doing the actual bare minimum, and that would be the most expensive ticket. So that can be done in this inequality. So that n is the number of trips. And then, just solving for n, we just divide, and the biggest whole number that matches this inequality is 28. So the minimum number of trips per month for a monthly pass to be worth the $95 would be 28 trips. Okay, the next question, ordered pair. So we have this system here. Y is less than or equal to x plus 7, and y is greater than or equal to negative 2x minus 1. What is the system? So you could do this in 2 ways. You can either graph both on Desmos and manually check, or you can just solve them out. So by solving it out, you can actually just plug it in. So for time's sake, I'll just plug in the correct answer, but you'll have to test each individual one. So plugging it in, this one works. Plugging this one in, it also works. So that is the way to find the correct answer. You can graph it on Desmos too and look for it manually. Just make sure you do it in the region that's shaded by both graphs. Okay, this question, a salesperson's total earnings consist of a base salary of X dollars per year, plus commission earnings of 11% of the total sales they make during that year. They have a goal of at least 3 times and at most 4 times the base salary. And this represents the total sales S in dollars. So we have to make this an inequality. Now, the total earnings they make is X plus 0.11, that 11%. And the way to find, so essentially we're finding S. And the way to do that is, we have to plug in our goal. So at least 3 times and at most 4 times. And then we just solve for S. So we subtract X on both sides, and then we just divide that 0.11, leaving this to be our correct answer. Okay, nonlinear functions. So we start off with g of x, and we're trying to find the product of g of 15a and 7a. So we actually just plug it in, and because a is less than 0, that absolute value of a will equal negative a. And that might be confusing for some of you guys, but because a is default negative, we can just assume that the absolute value of a is negative a. And that is because, when you have every value of a being negative, that absolute value is not like a result. It's just showing us what it yields. So in this case, it would yield negative a because every value of a is already negative. So just plugging in that negative a, we just, cancel out the a, and then, the a's cancel out, and you have negative 15 minus 14. Same thing for this one. We have that negative 7 minus 14 equals negative 21. And then multiplying those both, you get 609. Okay, we're looking for the y-intercept for this question. And g of x equals f of x over x plus 3. Y equals f of x. So that helps us out there. So again, we're looking for a y-intercept. But first, we can do, we can just rearrange this to equal f of x. And we'll just do that by multiplying x plus 3. And then we can plug in f of negative 27, because that's a number in the graph. And then g of x will equal 3 as well. So that will equal negative 72. And then f of negative 9 equals 0. So using these two values, we can look for the slope. Now again, we're looking for the y-intercept, which means b. And we can just plug in, the easiest one here is negative 9, 0. So we can just plug that in here. And we'll end up with b equals 36, meaning the y-intercept is 0, 36. Okay, value of t, we have h of x equals 2 times x minus 4 squared minus 32. And they intersect 0, 0, and t, 0, and t is a constant, and we need to find t. Now, we are given y equals h of x, which, considering it intersects the x-axis at 0, 0, we do know that h of t just equals 0 because of t, 0. And using that, we can, have our initial condition. And we have, h of t again. And in this case, it will just equal 0 because of that h of t equals 0. And that way we can solve for t. So we'll just move the 32 on the right side by adding it and then dividing by 2. And then we can square root. And whenever you square root, you need that plus or minus, because 4 times 4 and negative 4 times negative 4 both equal 16. So t will equal 0, 8, and 0, 0 is already an intercept given. So in this case, it will be just 8. Okay, the minimum value, when you have a minimum value, you can actually do something really simple, and you can either solve for the vertex, or you can just plug it in on Desmos and just find it. Now, when it says minimum value, that refers to the y value, so that will be 1,728. But be careful, because they will sometimes ask for that x value of the minimum or maximum, and there will actually be a question later that I will, relate this back to, so just be careful for that. But you can either solve for the vertex or just plug it into Desmos and find that minimum. So another y-intercept question, we're given f of x equals negative 8 times 2 to the x plus 22. Y-intercept is y equals f of x. So again, we do have a y-intercept, so x will just equal 0. So that's what we can do here. This one's more conceptual, just math. So that y-intercept will just equal 0, 14, because that's what happens when you do f of 0. So that's the main thing they want you to know. Just plug in x equals 0 whenever you're looking for a y-intercept. Okay, this question is that maximum value question I was explaining earlier. So this question just has, a whole lot of fluff. You don't really need to know the context, but we do need that y equation. Now, you can, again, just plug it in, or you can just use the vertex formula as well. Both work. Now, we are looking for x, so this vertex formula just works out better for us. I would recommend just plugging it into Desmos, but if you want to be sure and you want to use both and you have the time, feel free to do so. and then, x will just equal 7. Now, again, this question does say the value of x of the maximum, so not the y value, okay? So be on the lookout for that. Okay, y-intercept, another one, last question for today. The function f models the number of advertisements, and we're following x, that is the number of years after 1997. So x equals 0 just represents 1997. So keeping that in mind, we do have to just account for these answer choices that say during the 5 years. So that does make a difference, and this one is just in 1997. Now, I'm going to tell you guys now, when you have y-intercept, again, x equals 0. When x equals 0, we're looking at the starting point, which in this case is 1997. So in the context of this question, it will be, in 1997. Now we just have to figure out if the number of advertisements was 1,708 or 9,000. Best way to do that, again, y-intercept, you just plug in x equals 0, we have 9,000. And again, x equals 0 represents the year 1997, meaning this question, or this option, the estimated number of advertisements the company sent to its clients in 1997 was 9,000. So that's the last question for today. And again, these questions are all from the College Board, their test banks. So these are all, questions that have been on former SATs and, will likely be very similar to the ones that will be on future SATs. Again, if you like this video, please like and subscribe.